Welcome, cosmic explorers. Today, we're diving into one of the most profound mysteries of the universe, time itself. We experience it every second, but what is it? And what would happen if, one day, it simply stopped? Get ready, because we're about to embark on a mind-bending journey. The elusive nature of time. We measure it, we chase it, we often wish we had more of it. But ask a physicist, and you'll get a far more complex answer than a simple ticking clock. Is time a fundamental force, a dimension, or merely an emergent property of our universe? Newton saw time as an absolute, a steady river flowing independently of everything else. Einstein, however, revolutionized this view, showing us that time is relative, woven into the very fabric of space-time. It bends and stretches, influenced by gravity and speed. So, before we can imagine time stopping, we need to grapple with its incredibly elusive and interconnected nature. Einstein's revolution. Space-time. Albert Einstein's theories of relativity forever changed our understanding. He proposed that space and time aren't separate entities, but are interwoven into a single four-dimensional fabric called space-time. Imagine a trampoline. Heavy objects like planets and stars create dips in this fabric. What we perceive as gravity is actually the curvature of space-time, dictating how objects move. Crucially, time is the fourth dimension within this fabric, just as integral as height, width, and depth. This means that events aren't just happening in time, but time itself is a component of the universe's structure. Time dilation. The universe's stopwatches. One of the most fascinating consequences of space-time is time dilation. This isn't science fiction, it's a proven scientific fact. The faster you move through space, the slower you move through time relative to a stationary observer. Similarly, strong gravitational fields can also slow down time. For instance, an astronaut orbiting a black hole would age slower than someone on Earth. Even GPS satellites have to account for time dilation. Their clocks run slightly faster due to their weaker gravitational environment and high speed. These tiny, measurable differences confirm that time isn't universal, but relative to an observer's motion and gravitational influence. The arrow of time. Why does it flow forward? Why does time only move in one direction, from past to future? This is known as the arrow of time. Physics laws, at a fundamental level, are mostly time-symmetrical. They work the same forwards and backward. Yet we never see a broken cup reassemble itself, or an old man grow younger. The answer lies in thermodynamics, specifically the second law, which states that entropy, or disorder, always increases in a closed system. The universe is constantly moving from order to disorder, from low entropy to high entropy. This irreversible increase in entropy is what gives time its unidirectional flow. The Big Bang and the birth of time. If time had a beginning, then it's not eternal. Our current understanding points to the Big Bang as the genesis of not just matter and energy, but also space and time. Before the Big Bang, there was no before, because time itself didn't exist. It's a concept that challenges our linear thinking, but cosmologists believe that the universe, and therefore time, emerged approximately 13.8 billion years ago, from an incredibly hot, dense state. This implies that time is intrinsic to the universe's existence, rather than an external framework through which the universe unfolds. A universe without change, the immediate effect. Now, let's venture into the hypothetical. What if time simply ceased to exist? The most immediate and profound consequence would be the complete cessation of change. Motion would stop. Light, which travels at a finite speed, would freeze in place. Chemical reactions would halt. Even at the subatomic level, particles would no longer vibrate or interact. It would be a moment of absolute, eternal stillness. The universe would become a cosmic photograph, fixed forever in an instant. This isn't just a lack of progress, it's a lack of any process whatsoever, fundamentally altering reality as we know it. The fate of spacetime. If time is a dimension of spacetime, what happens to spacetime when time stops? This is where it gets truly mind-bending. One interpretation is that the four-dimensional fabric collapses into a three-dimensional static canvas. Without the temporal dimension, the universe loses its ability to evolve or change its spatial configuration. Curvature of space due to gravity would remain, but there would be no means for objects to move along these curves. Black holes would still exert gravitational pull, but nothing could fall into them. The very concept of event horizon would become meaningless without events progressing through time. Entropy's endgame. Remember the arrow of time and entropy? If time stops, so does the increase in entropy. The universe would be stuck in whatever state of disorder it was in at that exact moment. There would be no further decay, no further evolution towards thermal equilibrium. This means no stars burning out, no galaxies colliding, and no further expansion of the universe. The second law of thermodynamics, which underpins so much of our understanding of cosmic evolution, would essentially be rendered obsolete. The universe would be locked in an eternal, unchanging equilibrium, or disequilibrium, depending on when time ceased. Consciousness without time. What about consciousness? Our brains are intricate biological machines that rely on electrical impulses and chemical reactions, all occurring sequentially through time. Without time, these processes would simply stop. Thought, memory, perception, all would cease. There would be no now, no then. For any sentient being, existence would be an eternal, frozen instant of whatever their last conscious thought or sensation was. It's an unsettling thought, suggesting that consciousness, as we understand it, is inextricably linked to the flow and progression of time. Is it possible? The universe's future, can time truly cease? Current scientific theories don't offer a clear mechanism for time to simply stop everywhere simultaneously. Some theoretical models, like certain ideas within string theory or quantum gravity, explore scenarios where the nature of time itself might change at extreme scales, but a global cessation of time is highly speculative. However, understanding this hypothetical scenario helps us appreciate just how fundamental time is. It's not just a measure, it's the very engine of cosmic evolution, the framework for reality, and the canvas upon which all events unfold. What do you think would happen if time stopped? Let us know in the comments below. Don't forget to like this video and subscribe for more cosmic explorations. See you in the next chapter of the universe.